So let's start with our first type of chemical reaction, which is one of the most common one, combustion. Combustion means that you take metals and you burn them. You expose them to strong heat and you burn them with a flame. The chemical reaction is actually a combination between the metal and oxygen gas. All right, the metal and oxygen gas. So what you expect is that the end product will be a metallic oxide. Okay, so what about it? The most reactive metals like potassium, sodium, and calcium, well, they are really very reactive. We know the way, how reactive they are in the way that we protect them like crazy when we are storing them. So, can we burn them? Yes, theoretically we can. In reality, are you mad? So, if you should expose ridiculously reactive and unstable metals like potassium and sodium to a flame, not much heat is required. They will burn like crazy, and probably the amount of heat that's released will be a lot, and it will be all released at the same time. Even if you take away the fire, probably the amount of heat produced will be so much that the temperature that's reached will be able to carry on the burning by itself, and it is deadly dangerous. Okay, so this is something that belongs to the top tier of reactive metals. Now, if you go down to the next one, magnesium and aluminium, these are all reactive metals. Magnesium, very important. Burning magnesium is very famous for the fact that when it burns, right, first you have to heat it a little bit, then it can kickstart the burning. But the moment it burns, my God, the heat that is released is so tremendous that the temperature shoots up, and then the energy that's released will now be in the form of a very bright white light. Think in terms of camera flashlight, you know how it flashes in your eye, that brightness, that amount of energy as well. And the temperature is no slouch, it's in the 1000+ degrees Celsius. So it's no fun, but it does serve to show you how reactive magnesium actually is. Now, what about aluminium? No less reactive, people. Aluminium is so reactive that even if you just cut a piece of fresh magnesium and expose Al metal to just the surrounding air, even without the help of heat or fire, it will directly combine with the oxygen in the air and form a layer of aluminum oxide. That is just based on ambient temperatures and heat. So that kind of tells you exactly how reactive aluminium is, isn't it? But yes, we can heat it with a flame. It takes a little bit to kickstart. Then once it starts burning, you don't need the flame there anymore. Alright? The heat that is released would probably be able to maintain a high enough temperature to keep the burning going. Alright? Zinc is similar to aluminium as well. Alright? Then let's move on to the next one, iron and lead. These two are reactive in their own ways, but not towards burning. So these two, when you put them on top of a hot Bunsen flame and expose it to that flame for a while, it will start to burn, but you have to keep the flame there. Because when these two metals, iron and lead, when they burn, they don't produce enough heat of their own to maintain the burning process without the Bunsen flame. So you've got to keep the flame there. Then they will combine with the oxygen and form a layer of iron 2 oxide as well as lead 2 oxide respectively on each of these metals, and they will come with their own colors, which is what part of QA that you have to learn. I hope you find it useful. Click a like if you like it, and join my channel so that you can get updates for future video posts. Thank you.